Today, we may not be traveling through time, but a flying car may not be such a stretch anymore.
China has once again stunned the world by unveiling the AE200, a revolutionary flying transport vehicle designed to challenge and eventually replace conventional cars. But what exactly is the AE200?
In the future, the 3 or 2 years later, we can use the AE200. Just half or 13% of the cost than helicopter.
How does it work, and can it truly change our daily lives? Today, we explore this ambitious flying vehicle and others around the world, diving deep into the future of mobility. The AE200. At the heart of China's latest leap in transportation technology is the AE200, developed by Wuchongkong Technology based in Chengdu. This vehicle is not just another flying machine. It is a bold attempt to marry the vertical takeoff and landing (VTOL) capabilities of helicopters with the speed and range of airplanes. With a maximum takeoff weight of 2,500 kilograms, the AE200 sites comfortably in the category of light aircraft, but pushes the boundaries with its design optimized for urban air mobility. Its top speed clocks in at 320 kilometers per hour, which means it can cover distances that would take hours by car in mere minutes by air. This capability is crucial in megacities like Beijing, Shanghai, or Guangzhou, where road congestion can stall traffic for hours. By flying above the gridlocked streets, the AE200 offers not only speed, but also freedom from traffic unpredictability. The flight ceiling of 1,000 meters above ground level, or approximately 3,000 meters above sea level, allows the AE200 to navigate safely above urban environments and natural obstacles. With a flight range of 200 kilometers on a single charge or fuel load, it can connect city centers to suburban areas or regional hubs without the need for complex infrastructure. What truly sets the AE200 apart is its versatility. The vehicle is designed to function as a passenger transport system, emergency medical aid platform, and a general air transport solution. Imagine emergency responders deploying AE200 units to reach accident scenes swiftly, bypassing roadblocks and traffic jams, and delivering critical care faster than ever before. In June 2024, the AE200 underwent a series of public test flights that demonstrated full load performance and seamless transitions between hover and forward flight. These tests are more than just technological demonstrations. They signal readiness for commercial deployment, something that could happen sooner than many expect. However, the road ahead is filled with challenges: regulatory approvals, air traffic management, safety assurances, and public acceptance all require careful consideration. The AE200 is a promising technology, but integrating flying vehicles into the fabric of daily life will demand innovation beyond the aircraft itself. Could the AE200 be the first step towards cities where flying vehicles replace congested streets? And what challenges remain before this vision becomes reality? The engineering marvel. Flying vehicles have long been categorized as either helicopters or airplanes, each with distinct advantages and limitations. The AE200 seeks to unify the best of both worlds. Its vertical takeoff and landing capability is reminiscent of helicopters, allowing it to operate from confined urban spaces without the need for runways or large airports. This capability is essential for urban air mobility, where ground space is scarce and traffic congestion severe. Rooftop vertiports, or designated takeoff zones, become the new hubs, effectively expanding the city's transport infrastructure vertically into the sky. The AE200's ability to take off vertically reduces the time and space needed for travel, a feature that could redefine the future of commuting. Once airborne, the vehicle smoothly transitions into airplane mode. Fixed wings and aerodynamic designs allow it to cruise efficiently at high speeds, reducing energy consumption compared to helicopters that rely solely on rotor lift. This hybrid design is a significant engineering feat, requiring sophisticated control systems and precise aerodynamics. The AE200 incorporates noise reduction technologies, addressing one of the major public concerns about urban flying vehicles. Its rotors are designed to minimize sound pollution, ensuring that flying taxis or emergency transport do not disturb the urban environment. Onboard avionics include autonomous navigation, obstacle avoidance, and real-time traffic coordination. Such systems are critical to safely manage airspace, crowded with drones, helicopters, and other urban air vehicles. The goal is a seamless integration into the air traffic ecosystem, where ground-to-air and air-to-air communications maintain safety and efficiency. Moreover, safety is paramount. The AE200 employs multiple redundant systems, including backup power sources and emergency landing protocols. Passenger cabins are designed with crashworthiness in mind, and extensive testing under various conditions ensures reliability. Can the AE200's hybrid helicopter-airplane technology solve the urban transport puzzle while meeting safety and sustainability demands? The global race for flying transport. While China advances with multi-passenger flying vehicles, other innovators worldwide are focusing on personal aerial mobility. Poland's Volonaut airbike is a prime example, offering a single-seat flying motorcycle that combines speed, maneuverability, and futuristic design. Conceived by engineer Thomas Patan, the airbike evokes imagery from science fiction, resembling a speeder bike with its streamlined shape and exposed propulsion system. Unlike traditional helicopters with large rotors, the airbike uses a jet propulsion system, allowing speeds up to 200 kilometers per hour and enhancing safety by eliminating exposed blades. The airbike's compact size lets it navigate urban canyons and tight spaces inaccessible to larger flying machines. Its unique pilot seating provides a 360-degree field of view, offering situational awareness crucial for personal flight in dense environments. Stabilization is handled by an onboard computer that automatically maintains balance and hover, reducing pilot workload and making flight more accessible to non-experts. The vehicle's frame is made from ultra-lightweight carbon fiber using advanced three-dimensional printing technology, making it 7 times lighter than a typical motorcycle. Though still in prototype phases and yet to announce a commercial release date or pricing, the airbike has generated significant buzz. Enthusiasts envision a future where flying motorcycles supplement or even replace urban cars, offering personal freedom and reducing surface traffic congestion. Yet, challenges abound. Regulatory frameworks for personal flying vehicles lag behind technological advancements and questions of safety. Pilot training, airspace management, and public acceptance loom large. The Volonaut airbike embodies the broader trend toward democratizing flight, shifting from large aircraft to individual mobility devices, offering a glimpse into how personal transport might evolve in the coming decades. Could personal flying machines like the Volonaut airbike redefine freedom and mobility for urban dwellers worldwide? American innovations. In the United States, ALF Aeronautics has made significant strides by introducing a flying car officially approved to operate in American airspace. This ultralight vehicle bridges terrestrial and aerial travel, offering an innovative solution to the ever-growing problem of urban congestion. ALF's flying car boasts a flight range of approximately 110 kilometers and a road range of 322 kilometers on a single charge. The vehicle's ability to switch seamlessly between driving and flying modes makes it highly versatile, ideal for navigating city streets or soaring above traffic jams. Safety features include a built-in parachute system that can be deployed in emergencies, providing peace of mind for pilots and passengers. The company has amassed thousands of pre-orders, indicating strong market interest, with production slated to begin within the next 12 months. With a price tag around $300,000, the ALF flying car is positioned as a premium early adopter product. Still, its success could pave the way for more affordable, mass-market flying vehicles in the future. Beyond personal transportation, ALF envisions applications in emergency response, delivery services, and urban air mobility networks. The company's regulatory success sets a precedent, potentially smoothing the path for other innovators. Will ALF Aeronautics' flying car become the first in a wave of hybrid vehicles transforming American urban mobility? Emergency medical drones in China. In the realm of emergency response, China has pushed the envelope by unveiling what many consider a groundbreaking advancement: the world's first rescue drone capable of providing comprehensive medical assistance in the most extreme and inaccessible environments. Developed by Haishan Medical Technology, this drone is a marvel of engineering and medical innovation, designed to operate where traditional ambulances or helicopters cannot reach promptly. Equipped with an impressive array of advanced medical systems, the drone can deliver respiratory support, administer intravenous infusions, monitor vital signs, and even perform defibrillation. These capabilities transform it from a mere delivery vehicle into a fully equipped airborne medical unit. What is especially remarkable is the drone's ability to communicate in real time with doctors who are miles away, allowing specialists to remotely assess patient conditions and guide on-site operators in critical interventions. Built to withstand extreme conditions, the drone operates effectively in temperatures ranging from -25 to 46 degrees Celsius and can function at altitudes up to 5,000 meters. Such robustness means it can be deployed in mountainous terrains or during extreme weather conditions, making it an indispensable tool for disaster zones, remote villages, or urban areas suffering from congestion and delays. With a payload capacity of up to 300 kilograms, this drone can carry significant medical equipment and supplies. In emergencies, it can also evacuate injured individuals, offering a new paradigm for rapid medical extraction. While detailed data on flight range and battery life have not been publicly disclosed, expectations are high that the drone's endurance matches or exceeds typical operational needs within disaster zones. The significance of this technology cannot be overstated. Medical emergencies are often a race against time, and the ability to provide early interventions en route can dramatically increase survival rates. Furthermore, deploying drones reduces risk to human responders by bypassing hazardous conditions. However, challenges remain. Regulatory frameworks governing medical drone operations, airspace management, and patient privacy need to evolve to fully harness this technology. Integrating drones into existing emergency response systems requires coordination among hospitals, first responders, and air traffic controllers. The introduction of Haishan Medical Technology's drone hints at a future where medical aid is no longer constrained by geography or traffic. It raises important questions. Could airborne medical drones become standard in urban hospitals? How soon might we see a drone paramedic as common as an ambulance? And what ethical considerations arise when robotic systems take on critical care roles? As medical drones take flight, could airborne paramedics become the new frontline heroes in emergency healthcare worldwide? Filipino engineers Hoverboard Air. Personal flight has long captured human imagination, but turning it into a practical reality has been elusive. Enter Filipino engineer and innovator Kix Mandiola, whose creation, Hoverboard Air, offers a compelling glimpse into the future of individual aerial mobility. This multi-rotor aircraft is designed to lift a single person effortlessly into the air while providing stable, controlled flight. Hoverboard Air operates via a handheld remote, complemented by intuitive body tilting controls that make flying more natural and accessible even to beginners. Its stabilization system is engineered to ensure safety and comfort, allowing users to maintain balance and respond swiftly to environmental changes during flight. One of the remarkable advantages of Hoverboard Air is its compact size and portability. The device can be transported easily in the back of a truck, enabling flexible deployment across various locations, urban rooftops, remote work sites, or recreational areas. This portability is key to making personal flying devices practical for everyday use rather than niche enthusiast gadgets. Kicks. Mandiola's recent successful flight, covering over 2 kilometers in just over 7 minutes, is a promising proof of concept. It demonstrates the device's potential not only for recreational flying, but also for practical transport solutions in congested urban settings or difficult terrains. The materials and design choices for Hoverboard Air emphasize lightweight durability, critical for maximizing flight time and maneuverability. However, current battery technology limits continuous flight duration to relatively short periods, a common constraint among personal flying devices. Despite this limitation, the project represents a major step forward, inspiring further development and broader acceptance of flying boards as viable transport options. It also sparks broader discussions about regulatory frameworks, pilot training, and public safety in a future where personal aerial vehicles become more commonplace. Hoverboard Air joins a growing field of innovators worldwide aiming to democratize flight. Unlike traditional aircraft requiring extensive training and infrastructure, devices like Hoverboard Air offer more spontaneous, flexible flight experiences, potentially reshaping urban mobility, tourism, and emergency response. What remains uncertain is how quickly infrastructure such as landing zones, traffic control, and charging stations will evolve to accommodate personal flying devices. Additionally, questions about noise pollution, air traffic safety, and social acceptance will shape their integration into daily life. Could devices like Hoverboard Air transform the way we commute, or will regulatory hurdles and technology limits keep them grounded? The rise of personal flying devices. The dream of personal flight has captivated humanity for centuries. In recent years, the concept has shifted from pure fantasy to tangible reality, thanks to rapid advances in technology. From hoverboards to jetpacks, engineers and enthusiasts worldwide are pushing the boundaries of what's possible in personal aerial transport. The Chinese company Wuchongkong Technology made headlines with their AE200 flying vehicle, but the innovation doesn't stop there. Take, for example, the Polish engineer Thomas Patan's Volonaut airbike, a sleek single-seat flying motorcycle that resembles the speeder bikes seen in popular science fiction films. Patan's device is not just visually impressive, but technologically revolutionary. With its jet propulsion system, the airbike can reach speeds of up to 200 kilometers per hour, and thanks to its compact design and absence of exposed rotors, it can safely maneuver through tight spaces. The pilot's seating position grants a full 360-degree view, supported by a patented stabilization system that makes hovering and control remarkably intuitive. What's more, the structure is constructed from ultra-lightweight carbon fiber using advanced three-dimensional printing, making it 7 times lighter than traditional motorcycles. Such advances show a clear trend. Personal flying devices are becoming more practical, versatile, and accessible. While precise commercial release dates and prices for some of these devices remain under wraps, interest from tech enthusiasts and experts alike continues to surge. Could personal flying motorcycles soon become as common as motorcycles on the streets? Other innovators are adding their own twists to the dream of flight. For instance, the American company Jetpack Aviation has developed the JB-10, a compact jetpack capable of reaching speeds of up to 160 kilometers per hour and climbing to altitudes of 3,000 meters. Powered by 2 turbojet engines, this device allows pilots to experience flight with remarkable agility and speed. Its flight duration averages around 10 minutes, depending on weight and conditions, and it can be operated without extensive flight training, making it a remarkable leap forward in personal aviation. Beyond jetpacks and airbikes, we see innovative designs like the French company Zapata's Esfly, a personal flying Segway-like device that can reach speeds of 130 kilometers per hour and ascend to 3,000 meters. The Esfly simplifies flight controls with handles for balance, opening the skies to beginners and professionals alike. Its versatility makes it ideal for entertainment, rescue missions, and even military applications. The diversity of personal flying machines available or under development today is staggering. From hydro-powered jetpacks like the H3X, which propel riders above water using powerful water jets, to full-scale multi-rotor flying vehicles capable of carrying passengers over land and water, engineers are breaking old limitations. Filipino engineer Kix. Mandiola's Hoverboard Air is one such example. Capable of lifting a person and flying stable distances, this multi-rotor aircraft is controlled intuitively through body movements and a handheld remote, showing promise as a future mode of urban and recreational transport. With so many different flying machines taking shape, which will become the true successor to the conventional car in the skies. Challenges and realities. While the rapid development of personal flying vehicles excites many, the journey to widespread adoption is fraught with technical, regulatory, and societal challenges. Designing a flying transport that is safe, affordable, and practical for everyday use is an immense undertaking that requires not only engineering prowess, but also careful consideration of public safety and infrastructure. One major hurdle is flight duration and energy storage. Most personal flying devices currently operate on battery power or small fuel tanks that allow flights lasting mere minutes to a maximum of half an hour. Extending flight time while keeping weight and size manageable is an ongoing area of research. Battery technology, especially energy density and charging speeds, needs significant breakthroughs before flying devices can replace cars for daily commutes or longer journeys. Safety concerns are paramount. Unlike cars confined to roads and predictable traffic systems, flying vehicles must operate in three-dimensional space, avoiding obstacles, other flying craft, and dealing with variable weather conditions. Advanced autopilot systems and collision avoidance technologies are crucial, but even the most sophisticated AI and sensors cannot eliminate all risks. Emergency protocols, fail-safe mechanisms, and robust pilot training are necessary to prevent accidents that could be catastrophic. Urban airspace regulation is another significant barrier. Governments and aviation authorities worldwide must develop comprehensive frameworks for the operation, certification, and monitoring of personal flying vehicles. Issues such as air traffic control integration, noise pollution, privacy, and zoning regulations require careful deliberation. These challenges become even more complex when considering flying vehicles in densely populated urban centers. Moreover, the cost factor remains a major concern. While some devices are marketed at tens of thousands of dollars, widespread adoption depends on costs dropping significantly to become competitive with traditional cars or public transport. Mass manufacturing, supply chain stability, particularly for rare materials used in batteries and motors, and geopolitical factors affecting material sourcing all influence pricing and availability. The social acceptance of flying vehicles must also be considered. Public perception can range from fascination to fear, influenced by safety concerns and cultural attitudes toward new technologies. Infrastructure adaptations, such as rooftop landing pads, maintenance facilities, and emergency response systems for aerial incidents, would be required on a large scale. Despite these challenges, the momentum behind flying personal transport is undeniable. Companies and governments are investing heavily in research and pilot programs, while advances in AI, materials science, and energy storage continue to lower barriers. It remains to be seen which technologies will rise to dominance, but the idea that our future commutes may take to the skies is no longer just science fiction. Can innovation and regulation keep pace with soaring ambitions, or will the dream of flying cars face turbulence before takeoff? A glimpse into urban air mobility's future. China's unveiling of the AE200 flying vehicle represents a remarkable milestone in the rapidly evolving field of urban air mobility. Developed by Wuchongkong Technology based in Chengdu, this aircraft merges the benefits of both helicopters and airplanes to offer fast, efficient transport that can navigate the congested urban environments many cities face today. With a maximum takeoff weight of 2,500 kilograms and a top speed of 320 kilometers per hour, the AE200 is engineered for both versatility and performance. Its maximum operational altitude reaches 1,000 meters above ground level, or 3,000 meters above sea level, allowing it to bypass traditional ground traffic with ease. What truly sets the AE200 apart is its flight range of 200 kilometers, enabling practical use for short to medium commutes, medical emergencies, or cargo transport. In June 2024, the AE200 completed successful public test flights that included full-load operations and smooth transitions between helicopter and airplane modes. This successful demonstration marked a significant proof of concept, showing the aircraft's potential to redefine urban transportation. One of the most compelling aspects of the AE200 is its multifaceted role. Beyond passenger transport, it is poised to serve in emergency medical assistance, providing rapid response capabilities in scenarios where ground vehicles might face delays. The ability to quickly deploy medical equipment or evacuate patients from hard-to-reach locations makes it a potential game-changer for urban healthcare systems. Moreover, the aircraft's design emphasizes efficiency in crowded cities, where traffic congestion often leads to lost time and productivity. The introduction of the AE200 adds to China's broader vision for low-altitude transportation solutions that are environmentally conscious and technologically advanced. Wuchongkong Technology's focus on commercialization suggests that these flying vehicles may soon become an integral part of city infrastructure, with dedicated landing zones and integration into existing transportation networks. The question that lingers is how quickly cities worldwide will adapt to accommodate such innovations, and what regulatory frameworks will be established to govern their use. With AE200 showing promise as a practical urban flyer, could China be on the cusp of launching flying taxis that revolutionize city travel? How other countries are pushing flying transport forward. While China's AE200 captures headlines, the global race to develop flying transport solutions is intensifying across many nations, each bringing unique innovations and strategies to the table. From the United States to Europe and Japan, companies and governments are investing heavily in personal and urban aerial mobility, pushing the envelope of what flying transport can achieve. In the United States, companies like ALF Aeronautics have introduced flying cars that blend road and air travel capabilities. Their flying car prototype boasts a flight range of approximately 177 kilometers and can also travel over 322 kilometers on the road without recharging. This dual capability allows users to seamlessly switch between driving and flying modes, a feature that appeals to consumers looking for flexibility in their daily commutes. The vehicle has received official approval to operate within US airspace, a critical step for commercialization, and the company has already reported thousands of pre-orders, signaling strong market interest. Across the Atlantic, France's Zapata company has made waves with the ESFLI personal flying device, a compact and highly maneuverable craft designed for both entertainment and practical uses such as rescue operations. The ESFLI can reach speeds of up to 130 kilometers per hour and climb to altitudes of 3,000 meters, combining performance with intuitive controls that even beginners can master. Such innovations highlight a shift toward making personal flight accessible to a broader audience beyond just specialized pilots. Japan's SkyDrive has been working on the SD-03, a single-seat flying car with vertical takeoff and landing capabilities designed specifically for urban environments. Its compact size allows for easy navigation of cityscapes and the use of rooftops or specialized pads as landing zones. With its fully electric powertrain, the SD03 emphasizes environmental responsibility alongside cutting-edge technology, aiming to meet modern emissions standards while offering a quiet and efficient mode of transport. New Zealand's Martin Aircraft Company has developed a personal vertical takeoff and landing vehicle known as the Martin Jetpack. Powered by a gasoline engine and ducted fans, it can ascend to 2,500 meters and reach speeds up to 74 kilometers per hour. Despite some setbacks in funding and operations, this jetpack represents a significant advancement in personal flight technology and continues to attract attention for both commercial and emergency applications. These examples represent just a fraction of the worldwide efforts to bring flying transport to everyday life. From the experimental to the near-commercial, the competition is fierce and fast-paced. The convergence of artificial intelligence, battery technology, and advanced materials science is accelerating progress, but questions remain about infrastructure readiness, regulatory harmonization, and public acceptance. As countries race to dominate the skies, will a single technology emerge as the winner, or is the future of flying transport destined to be as diverse as the inventors behind it? Flying rescue and emergency response. The development of flying transport is not limited to passenger mobility or personal travel. A growing and crucial segment is the use of aerial vehicles in emergency response and disaster relief. China has recently unveiled an extraordinary rescue drone developed by Haishan Medical Technology that is designed to operate in extreme and hard-to-reach environments, showcasing how flying transport can directly save lives. This innovative medical drone, equipped with an impressive array of advanced medical systems, is capable of delivering respiratory support, performing intravenous infusions, monitoring vital signs, and even carrying out defibrillation. Real-time video communication features enable remote doctors to monitor a patient's condition and provide guidance to on-site operators. Such capabilities redefine what remote emergency medical services can achieve, especially in regions where road infrastructure is damaged or inaccessible. With a payload capacity of up to 300 kilograms, the drone can carry substantial medical equipment or evacuate injured persons, a feature that may dramatically improve rescue operations in mountainous terrain or disaster zones. Its ability to function in temperatures ranging from -25 to +46 degrees Celsius and operate at altitudes up to 5,000 meters highlights its suitability for a wide range of climatic conditions. The potential impact of this technology is vast. Imagine a scenario where an earthquake strikes a remote village and traditional ambulances cannot reach victims quickly. A flying rescue drone could navigate directly to the site, provide life-saving treatment, and even evacuate patients to hospitals far faster than ever before. Moreover, its capability for real-time communication creates a new paradigm for telemedicine in crisis situations. Could these flying medical drones soon become a standard fixture in emergency services worldwide, transforming how we respond to disasters? Personal flight takes off. While large-scale flying vehicles make headlines, the fascination with personal flying devices like hoverboards and jetpacks continues to captivate inventors and enthusiasts alike. Around the world, engineers are pushing the limits of what a single person can pilot, blending technology, innovation, and a touch of science fiction to create new possibilities for flight. Filipino engineer and blogger Kix Mandiola has captured attention with the successful test flight of his Hoverboard Air, a multi-rotor aircraft capable of stable flight while carrying a person. Covering a distance of over 2 kilometers in just over 7 minutes, this device demonstrates the potential of compact, personal air transportation. Controlled with a handheld remote and pilot body tilts, the Hoverboard Air emphasizes intuitive flying. with a stabilization system ensuring safety and comfort. Its portability, transportable in the bed of a truck, hints at a future where personal flight devices may become as convenient as personal vehicles. Further afield, New Zealand's Martin Aircraft Company has developed the Martin Jetpack, a personal vertical takeoff and landing vehicle powered by a gasoline engine producing approximately 200 horsepower. The jetpack is capable of speeds up to 74 kilometers per hour and can reach altitudes of up to 2,500 meters, with flight durations of approximately 30 minutes. Although the company faced financial challenges, recent efforts are preparing the project for revival, signaling sustained interest in practical jetpack flight. Meanwhile, American inventor Hunter Cowell has revealed a functional hoverboard drone featuring 8 large propellers capable of lifting a rider to heights of 150 meters. Made of carbon fiber for strength and lightness, the device supports payloads up to 227 kilograms and achieves flight times of around 20 minutes. Cowell's commitment to safety, including redundancy for motor failure, sets a high standard for personal flight innovation. Thanks for watching. If you enjoyed this look into China's flying transport revolution, hit like, comment your thoughts, and check out our next video for more futuristic tech updates.